And now for finding area. This is a parabola, an upside down parabola, and I'm going to go ahead and graph it. If you look at the graph, there's the upside down parabola. And it's crossing the x-axis over here at -2. And over here at +3. So I want the area that's above the x-axis. So that's talking about this area in here. And then estimate by using 5 rectangles. So first of all, I need to take this line right here from -2 to +3 and divide that into 5 equal parts. That's also known as delta x. So delta x, take the length of the interval, which you get from taking 3 minus -2, and then divide that into equal pieces. Well, this is actually going to be 5 divided by 5, so delta x is equal to 1. So right here would be -1, and then 0, +1, +2, and +3. So now this has been divided into 5 equal parts. Now make the rectangles. So when you use this interval right here, then start making a rectangle. So I could use the right endpoint, plug that in, and then the rectangle would be sticking out like this, and it would not be a very good estimate. So instead, I'm going to use the midpoint. So right here between -1 and -2 is -1.5, and then take that and plug it in. And it's not going to fit the graph perfectly, but so right here, it's missing some area, but then again, right here, it's got some extra. So if you cut that off and fit it in there, it would almost fit. So using the midpoint is going to be the best estimate here. And then you do that for the next one, the next one, the next one. And then the last one is going to be right here. So for this interval, we'll use the midpoint, which is going to be 2.5. Take that value, plug it into the function, and then use that as the height of this rectangle. And so in total, there would be 1, 2, 3, 4, 5 rectangles, and then add up the area for each one. So I could do that by hand and actually plug in all of these decimals into the function. Or what I could do is have the calculator do it. So I'm going to have the calculator do it by using sum, the sequence. And then you have to tell it the area of each rectangle. Well, the area is the base times the height. Well, the height comes from taking these numbers and plugging them into the function. So that's going to be the function will give you the height of each rectangle. And then each one has a base of delta x. So multiply by 1. And you might be thinking, well, what about the 1.5? Well, here it comes. You then say comma x, and then start at the -1.5. Keep going until you get to 2.5. And then the last thing is you need to tell it delta x. So that last delta x right there means it's going to start at 1.5, and then it's going to add 1. So then that would be -0.5. And then it's going to add another 1, and that's going to be +0.5, etc. And it's going to keep going until it gets to 2.5. So now to do that on the actual calculator. So let me just get out of that screen. So you go right here to list. So second list, move over to math, and sum is number 5. Then go back to list, second list, go over to operations. Number 5 is the sequence. Then tell it the expression. Now, if your operating system is a little bit older, it doesn't exactly look like this, but you'll just type exactly what you see right here. So on this operating system, you can type the function, and then that would be times delta x. But in this case, since it's times 1, I don't really need to type times 1. The variable we're using is x. Start at negative 1.5 and go until you get to 2.5. And the step means the delta x. Paste just means put it on the home screen. And so it says that the area is approximately 21.25. Now I want to check my answer. If you go to the graph and you go to calculate, number 7 will find the area. Lower limit, that means start at negative 2. So this is finding the exact answer. It's not using approximations. So it's going from negative 2 to positive 3, and it finds the area and even shades it. So the actual answer is 20.833. Our estimate of 21.25, it's not too bad, especially considering we only used 5 rectangles.